Good afternoon. I'm Mike Cully. I'm the founder and CEO of Sister. We're a Canadian company based in Ontario, Canada. I'm actually based out of Georgia, so we had a good night last night at the football. No offense to anyone from Texas here. As was indicated, we're taking an industrial technology, ultra high pressure water jets, and applying them in row crop planting applications. And okay, so we all know the promise of no-till farming and cover crops, but by definition, those practices come with heavy crop residue on the field. And that, as that residue builds up season over season, because we want to stay in no-till and cover crops forever, if possible, it gets more and more difficult to cut through with today's technology, which would be a metal coulter or disc cutting through that technology. What tends to happen is instead of the residue getting cleanly cut, it gets pushed or hairpinned into the soil, so that when the seed is deposited, it no longer touches soil, but is touching residue. And that inhibits seed germination and growth of the plant. Our calculation says that up to 500 million bushels of corn and soybeans are lost each year due to hairpinning, just in the North American region. Now today, farmers have a few tricks up their sleeves that they try to overcome this. The most basic is you start applying downforce and pressing down harder to cut through the residue. Unfortunately, if you imagine pushing all that weight down on a knife edge, what that does is it ends up causing compaction under the cutting edge of that planter, which inhibits the root growth. The other thing that farmers do is they add a whole Christmas tree of attachments to their planters to try to push the residue away. And we know that those attachments are only partially effective because the average no-till farmer ends up tilling their soil every 3 or 4 years and negating the benefits of staying in permanent no-till or cover crops. Now, our solution is to take an industrial technology, ultra high pressure water jets. They're used in manufacturing to cut through metal and pump water at 60,000 pounds per square inch. And what we're doing is that we are applying them as a new attachment on the planter. And so you can see on the front of this planter, there's a new row units that we put on the planter with our water jet system. And this infographic shows that as the planter is engaging in the ground, the jets are digging into the heavy residue that you see there. Now, surprisingly, this system uses very little water to cut through the residue. It only uses about 10 gallons of water per acre if you're looking at a 30-inch row widths moving at about 6 miles an hour. Actually, the faster that the planter moves, the less water it's using because you're spreading that water over the speed of the planter. We do require power for our system. We require about 12.5 horsepower per row to run our system. Now this shows, and then you'll see what happens. So we have 2 variations of the product that we offer. We can offer a system that runs on a PTO basis. We do offer a cart in the middle that has the water tank, and it can either control the system, the intensifiers we call them, which pressurize the system, or they can hold engines as well. So if you think about that 12.5 horsepower requirement, if you had a 12-row planter, you need about 150 horsepower to run our system. So if you had that plus the planter, you would need a tractor, if you're going to be PTO driven, of about 300 horsepower to run our system. If you don't have a tractor that's 300 horsepower, then we can provide the system with an additional engine on the system to run our hydraulics in the field. The system's been in the works for about 10 years. It's actually technology that started out in Australia. The Australian government was testing it. And then one of the engineers who works with me brought it to North America and had been working on it about 4 rounds of prototyping over the last 6 or 7 years. In 2022, we for the first time did what I would call commercial grade testing of the product, meaning that we tested a commercial size system. We did that at the locations you can see here. We were at 7 different field conditions over 3 states and in Ontario as well. The results that we found in 2022 were really exciting for what we saw. Just to give you an example, on the left here, we're in Murray, Kentucky, and we planted corn over heavy corn residue. Now the interesting thing is mid-season, we went out there and we saw this effect that the rows that were planted with our technology were noticeably taller than the rows that were planted with the farmer's own technology. Same variant of corn, same planting population, everything, but it was taller. We thought that was interesting, but we got a little nervous and said, okay, are we actually producing higher height at the expense of yield? But when we harvested at the end of the year, we saw that our rows produced a yield that was 6% higher than the rows that were planted with the farmer's technology. In Puryear, Tennessee, northern Tennessee, we did double crop soybeans in June. So we harvested wheat one day in June, and the very next day we planted soybeans into that wheat in terrible drought conditions, I must say, last year. You can see about a month later, the cister rows were emerged. I would call that poor emergence for a month. But you can see on the left where the farmer planted, it was very scraggly emergence at that time. In the end of the season, his beans, there was late season rain, his beans did come up, but at the end of the day, we had about an 8.9% yield increase over what the farmer planted. In Belmont, Iowa, we planted soybeans over 2 seasons of corn residue, plus a cereal rye that was about chin high when we planted in the field. Again, about mid-season, you can see that both the farmer and cister had emergence, but if you notice, ours is pretty uniform emergence, but what the farmer had were these gaps in the emergence, and that's where the hairpinning had occurred and the crop didn't come up. And there we had over a 12% yield increase over the farmer. This is our table that summarizes the value propositions that we claim for our product and how we tested those this year. We talked about yields already. We saw a noticeable yield increase. We suspected there would be one based on the prototyping, but we had never measured the yields side by side. When I say move towards never tilling again, that's the ability of our system to plant in what I would call near unplantable conditions. That can be heavy clay conditions. In Savannah, Tennessee, we planted on extremely compacted ground on river bottom, not compacted due to machinery, but due to the fact that the ground floods up to 10 feet every spring, and that it caused a natural compaction of over 400 PSI. We did side by side there. The farmer with his current John Deere planter could only plant the soybean seed about a ½ inch down in the compacted soil, and we were able to plant a full 2 inches down. They're still working on the yield results from that study. In West Liberty, Iowa, we planted on land that had been in the CRP program for 20 years. So if you can imagine a meadow, we were planting straight into the meadow. The farmer put his own planter out there, cracked the toolbar, and was done for the day. We put our system out there and we were able to plant through what I would call the most extreme cover crop you would ever see. And again, we had a pretty good emergence and we're just waiting for the data out of the combine today. But because we were able to plant in these extreme conditions, we feel that we're very confident that we could plant in almost any condition on a standing cover crop or in any residue condition that you could find. Expanding the planting window, this is something that's very exciting. As you know, when you plant and you have damp residue, you have to wait for the residue to dry out to a certain degree today before you can go out and cut. Our system works extremely well in wet conditions. So as long as you can get a tractor in the field, so not a mud pit, but if you can have a tractor in the field, you can have damp residue and our system will cut through the residue and plant correctly. That literally could add hours to the farmer's planting day. And then of course, reducing chemical runoff. If you use a starter fertilizer like a UAN 28%, we actually could use that as the cutting fluid in our system. You could pump it through our pumps, use it to cut through the residue, and then we inject it about 3 or 4 inches into the soil. So not only you've got a double purpose for your starter fertilizer, plus we get it down in the soil where it won't wash off the field. And then better germination and root growth. We saw that through our testing as well. All of that adds up in our calculation of a payback of about 2 planting seasons for a farmer. It is a full system. When you think about the power cart and the row units that come with it, it's not a cheap system. But due to the effects of having additional time to plant, getting the yield increase and more efficiency out of your seed and chemicals, we calculated a 2-season payback. And we've created a payback calculator so we can sit with farmers and go through their conditions and try to calculate exactly what the payback would be for them. What we've also noticed that we are very good in what I would call no-till conditions, and there's no-till conditions and then there's really no-till conditions. Some of the farmers tried to get us to farm on corn residue that I would consider fairly light on the field. And what we noticed is the higher the crop residue, the more difficult the condition, the better the payback was for the Sustera system. That's where we really perform versus today's technology. So if you're looking at things like multiple seasons of residue or cover crop green planting, that's where the Sustera system would be really effective. One farmer commented that he thought it'd be extremely good on genetically modified corn, where the residue seems to be getting more and more difficult to cut through. And so we would agree with that as well. This is where we're growing our presence in North America. Like I said, we're headquartered out over there in the east in Ontario. And we're focused primarily on the Corn Belt. We built this first system for wide width application, meaning corn, soybeans, sorghum, those sorts of crops. There was just a practical reason as a startup that we did that, is when you have 15 to 30 inches of space, it's just easier to install the row units on the planter. In the future, we'll move towards narrow row widths for wheat, canola, and other small grains. But right now we're focused on the Corn Belt, and we're actively starting to grow our operations in North America. We're likely to open an office in Fargo this coming year, and probably somewhere down in Tennessee, perhaps in Iowa as well. And then in 2024, we'll be looking in kind of the Illinois, Indiana area, and then out west in Kansas, Texas area. We are a lean organization. The purpose of this slide is to show that we're working with other specialists in the industry. iCubed is a company out of Ontario that focuses on custom engineering solutions. As you know, the jet system is standard, but the installation on a toolbar is fairly custom. No 2 planters are the same. So we have to, for each installation, have a semi-customized installation. That's their specialty, and we're working with them for manufacturing and design. And then Hypertherm is one of the world's leading suppliers of water jet technology, and they are our supplier of our water jets as well. So I want to thank you for listening, and I don't know if anyone has any questions.
Where did that rig you had that tank in that way?
I'm sorry?
Where did that tank weigh that you had for that plant?
The whole tank, the fully built one, and that had a 1,500 gallon water tank on it, was about 25,000 pounds. We did do compaction testing as part of the testing, so we went out and measured compaction with agronomists as we were planting versus the farmer's technology, and we did not notice any additional compaction that we were causing with our system.
So, any concerns on seed depth, placement, and how that may vary as you go across the field and run into different soil types?
Right. We're still using, so one technical detail that I didn't explain in detail, our cut is extremely narrow. It's about 0.01 of an inch, not even the width of a seed. So we're still using the planter's own openers to determine seed depth. So we're creating that initial passage. Our jet points backwards at the opener and hits the ground about less than a 1/4 inch before the opener.
Those images prior to going in, the ground, way more than 21 inch.
That's a bit of a misnomer. It's a weird situation. You can imagine 60,000 pounds is extreme pressure. However, if you remove the jet from the ground and pointed it sideways, it dissipates in the air almost immediately. So within 2 feet, you could probably put your hand against it and it would be safe. That was for illustrative purposes only. In real life, the jet doesn't start until the planter is engaged into the ground, so it maintains that focused cut.
Any, closing wheel requirements?
Any
Closing wheels?
Yeah, we do. We use the existing closing wheels.
Standard closing wheels?
Yeah, I'm sorry.
Standard closing wheels?
Yeah, depending on what the farmer, sometimes we use spikes, sometimes we use rubber wheels, just depending.
How durable are the jets? How durable?
Oh, the jets?
Yeah.
Yeah, so they're made to, run several thousand hours, so, they're pretty much gonna run. There is a little jeweled piece on the top called an orifice. It's usually a ruby or something like inexpensive, it's not jewelry. Those can occasionally come, dislodged, but they're very easily to replace and they cost pennies, to replace them. One piece of our design is built around, air inflow to protect, the jet from getting mud splashed back up on it, so it doesn't dislodge that orifice.
And then you said something about changing the depth for applying fertilizer. Is that something that you do on the fly, or is it something that?
No, that just basically goes, and basically it doesn't go down as a straight jet. And in fact, this week we're getting our results from a university. What we think is happening under the ground is when the jet hits the ground, it's actually fracking under the ground and decompacting the soil. But it does seem to disturb the soil about 3 or 4 inches below that cut.
The $325K investment was for how big of a planter?
That one would be of a 24-row planter with the cart. And then there's additional applications that we have as well. For instance, we're designing a side dressing attachment that could use the same cart that they go in mid-season to inject chemicals into the field.
So when you're using fertilizer as your cutting medium, does it have to be a true liquid? Can you use suspensions? Can you put any other products in with it?
So right now, we know that, for instance, the UAN 28% is safe to use through our jets. Depending on how caustic and thick they are, we can take inputs into our jet system in 2 ways. One is to put it through the pump with the jet. The nozzle also has openings for 2 additional inputs to be added into the stream immediately before it goes into the ground. So it wouldn't go through our jet, but it would go down a drawing tube and be injected into the fluid right at ground level and be added in. So if it was something that we weren't sure about the effect on our system, we'd probably run it that way into the ground. We have not tested it on granular inputs as well yet.
Mike, do you want to make a closing comment?
No, I'll be around. Come see me. I'd love to talk about the system as well.
All right, thank you very much for that.